Hello, students! As an important component of a circuit, power supply provides electrical energy to the circuit. In a specific circuit, we will use specific component symbols to represent it. Today, we start with the voltage source to understand the energy provider of a circuit, power supply. In a broad sense, can convert non-electrical energy into electrical energy. Devices that provide power to electrical appliances are all called power supplies. Commonly used power sources include dry cells, solar cells, thermal power generators, hydroelectric power generators, nuclear power generators, and so on. Voltage source, also known as an ideal voltage source, is a model abstracted from an actual power source that always maintains a certain voltage across its terminals, regardless of load variations. Due to various factors such as internal resistance and others, the ideal voltage source does not exist in reality. However, the ideal voltage source is highly valuable for circuit analysis. The component model we see in the diagram is that of an ideal voltage source. In reality, if a voltage source exhibits minimal voltage fluctuations, when the load changes, we typically make the assumption that it is an ideal voltage source with a relatively stable output voltage, such as generators, dry cells, or rechargeable batteries. The voltage source model is commonly used in such cases. The ideal voltage source is a component that is connected in series with a resistor. The diagram we see below represents the component model of a practical voltage source. In addition to the ideal voltage source, a series resistor R0 is added. The ideal voltage source has a negligible internal resistance, about 0, which results in a constant output voltage. However, real power sources always have internal resistance. Therefore, in the practical voltage source model circuit, when the load current increases, the internal resistance inevitably increases and consumes power. As a result, the output voltage decreases as the load current increases. Therefore, the external characteristics of a practical voltage source have a slight downward slope. We can observe the following characteristics of a voltage source. 1. The voltage at the terminals of an ideal voltage source remains fixed and unaffected by the external circuit. 2. The current flowing through an ideal voltage source depends on the external circuit to which it is connected. 3. When the voltage value of the voltage source is 0, it can be considered as a short circuit. This concludes this section. Let's ponder on the following questions. Are the voltage magnitude of an ideal voltage source and external circuit related? What is the internal resistance of an ideal voltage source? See you next time!